Alright, so for our example here, we have a researcher wishes to investigate whether students' scores on a college entrance exam, which we'll call CEE, have any indicative power for future college performance as measured by GPA. In other words, he wishes to investigate whether the factors CEE and GPA are independent or not. He randomly selects 100 students in a college and notes each student's score on the entrance examination and his grade point average at the end of the sophomore year. He divides entrance exam scores into 2 levels and grade point averages into 3 levels. Sorting the data according to these divisions, he forms this contingency table we see below. Alright, so we want to test this at the 1% level of significance, whether these data provide sufficient evidence to conclude that CEE scores indicate future performance levels of incoming college freshmen as measured by GPA. Alright, so let's first start with our hypothesis test. Our null will always look the same when dealing with these chi-square problems. Alright, so we want to say CEE and GPA are independent. Our alternate hypothesis is always going to be the opposite of that. They are not independent. Now, despite these English versions of our null and our alternate hypothesis, the alternate hypothesis on a chi-squared test is always right-tailed. So let's keep that in mind. Alright, now our next step is to find our critical value given a 1% level of significance. Alright, so we need to go first and get our, let me go down here, and at the bottom of your 11.1 notes is the link to the chi-square distribution. And that is very, very small. So let me see if I can make it a little bigger for us. Still not. How about that? Yeah. And we're going to have to arrow down or scroll down to find chi-squared. Okay, there it is, critical values of chi-square distributions. Now notice, to use this distribution chart, it's a right-tailed distribution on the chart. So, in other words, we're going to be able to just look up our alpha value of 0.01. But we need to know the degrees of freedom. So, just so we understand how to do that, let's go back here for 1 second to find those degrees of freedom. Oops, not that one. There we go. Alright, now, to get the degrees of freedom, and I'll just go right beneath where I've written critical value here, we want, you can think of it as number of rows, not including the total row, minus 1, and number of columns, not including the column totals, or the totals that are over here. There are 3 columns. So 3 minus 1. It breaks down to the number of divisions in each of the 2 factors. Alright? And that gives us 1 times 2, or 2 degrees of freedom. So we want to look up 0.01 level of significance with 2 degrees of freedom. So if I go back to my chart here, here's 2 degrees of freedom. 1 over to 0.01, that gives us a critical value of 9.210. Alright, now, recall I said these are always right-tailed tests. So we're going to do our test statistic, which is a bear. We're going to do that test statistic, but it needs to be to the right of 9.2 or bigger than 9.2 in order for us to reject the null hypothesis. Okay, so I said that getting that test statistic is a bear, and it is. So here's what we're going to do. We're going to amend this table up here, and I know the book is kind of difficult to read and figure out what it is you're doing, but here's what we're going to do. All right, so up here where it says 35, all right, I want to look at the total that goes with it in both the column and the row. So if I take the total that's here, that's 41, and then the total that's over here, that's 52. I want to take 41 times 52 and divide it by the total we have right down here, 100. So it's going to be 41 times 52 divided by 100. And if I do that calculation, that ends up being 21.32. All right, I'm going to just amend my table up here and put this right below it. All right, now I've got to do that for every single item in my table. So for the 12, let's notice the number that is below it is a 36, and over here to the side is 52. So it's going to be 36 times 52 divided by 100. And when I put that into the calculator, I end up getting 18.72. And if I keep going, now I'll go ahead and amend it right here, 18.72. Now rather than doing all of these calculations down below, if I did the same thing here, 23 times 52 divided by 100, I get 11.96. And for the 6, it'll be 41 times 48 divided by 100. And that's going to end up giving 19.68. And then for the 24, it'll be 36 times 48 divided by 100. That will end up being 17.28. And then finally for the 18, it'll end up being the 23 times the 48 divided by 100, which will give us 11.04. All right, so once we've done all of those calculations, we're ready to find our test statistic, our chi-squared test statistic. Now, rather than type out chi-squared using Word, I'm just going to put test statistic. And it is chi-squared. But all right, so our test statistic, what we're going to do is rather complicated. We're going to take what's in each of these cells, and we're going to take the top number minus the bottom number. So in this case, 35 minus 21.32, and we're going to square that. So squared, and then we divide by the bottom number, 21.32. And we do that for every single cell. So we'll have 12 minus 18.72 squared divided by 18.72. And notice I'm adding each one of these. So if I go to this one, 5 minus 11.96 squared divided by 11.96. And then 6 minus 19.68 squared divided by 19.68. And then 24 minus 17.28 squared divided by 17.28. And lastly, 18 minus 11.04 squared and divided by 11.04. And if we put that long and horrible thing into our calculator, now for your sake, I'm going to do each decimal so you'll know that you're getting the right thing. So our first fraction gives us this. Second one gives us this. Third one gives us this. Fourth fraction gives us this. Fifth fraction gives us this. And the last fraction gives us this. So if you'll do each fraction separately and make sure you're getting the right thing and then add them all up, we get 31.6813. Now notice our test statistic is in the critical region. It is to the right of 9.210. Alright, so it is in the critical region, which means we reject the null. Alright, now in this instance, if we're rejecting the null, we're embracing our alternate hypothesis, which means there is enough evidence to suggest that CEE and GPA are not independent. I'm going to move this over. Okay. And then, of course, we can state our alpha value is 1%, so alpha equal 0.01. Okay? And there we go.